Welcome, welcome back to the second part of this morning session on renewable integration and how we can ensure a stable grid operation when dealing with a high amount of renewables. So in the beginning, we already had presentations from distribution network operator, from the Austrian transmission network operator, and from TU Delft. To, let's say, round up the speakers, we have now a presentation from Verbund Hydropower. And I would like to introduce Mr. Wilfried Reich from Verbund, who will share his insights on the asset development of hydropower plants towards reliable flexibility. So, Mr. Reich, the floor is yours.
Yeah, thank you very much for the kind introduction. As already mentioned, I'm from Verbund Hydropower, a generation company. So one of these kind of bit boring companies, as we heard this morning from our colleague at Siemens. In my presentation, I would like to give you some insights about our company and about what we are doing, and above all about our contribution to a stable grid operation. So I will start with some information about the Verbund Group and Verbund Hydropower, also give you some additional insights into our new business field of hydro consulting, and over input about our generation portfolio. We will come to the subject of pumped storage power plants, which we find is a very valuable source of flexible operation already now for decades and also for the future as we think. Now, Verbund Group, at a glance, we are Austria's leading electricity company. We are operating 128 hydropower plants and generating about 30 terawatt hours per year. We are listed at the stock exchange in Vienna, although we are owned 51% by the Republic of Austria. As already mentioned, 128 hydropower plants represent more or less 95% of our generation, so almost everything is coming from renewable sources. Verbund Group is not only active in the generation but also in the whole electricity value chain, as you can see. Also transmission by our colleagues from Austrian Power Grid. One had a session before me. Also in the trading and the retail business. As you can see, we have 400,000 residential customers and also quite a big share in the industrial customers. Now we concentrate basically on Verbund Hydropower, where most of our generation is done. Just a quick insight into our organization. Verbund Hydropower is responsible for the planning, construction, refurbishment projects, and the operation and maintenance, of course, of all our hydropower plants, 128, as I said. And we're doing this now since 70 years. This is why you see this nice little logo on the right upper edge of the slides. We are organized more or less in two columns, let's say. In an engineering and maintenance division, we're having around 250 engineers there of different professions, like mechanical, electrical, civil high pressure, civil low pressure part. And the second big column is the operation itself, which is organized into several operational groups, 8 in Austria, one in Germany. And a rather new business unit is our unit of hydro consulting. I will come to that in the next slides then. What are our targets? The words you can read here, you will read on almost any presentation of a generation company. Of course, we are looking for safe and available and efficient generation. We want to be a sustainable producer, and flexibility is also on the list. This becomes more and more important as we shall see. And all this we should manage by still being cost efficient also. So a cost leadership is also one of our targets. So we are doing this since 70 years, I told you, and we have gained quite an experience in our business. We decided now, quite some time ago, also to use this experience and to go to the external market, to the international customers, which would require such know-how, which lack having it in their own stuff. That's why we started doing hydro consulting business. Just a few slides on that. What is it? What do we actually offer in that business field? It's generally, in very simple terms, all and everything on services which is required for the whole plant life cycle of a hydropower plant, starting from the first project idea up and until to optimization measures and refurbishment projects and so on and so on. Don't want to lose too many words here, just highlight one column or one big part where we see the core of our business, really, our hydro consulting business, also which we call is the asset management, where we offer operation and maintenance services, also long-term service contracts in the international markets, but also consulting services for assessing existing power plants, trying to identify optimization or even or improvement measures, and also support training and organizational development. Few references, what have we done in that regard in the last year? We just have finalized a 15 years O&M contract for power plant at the Euphrat in Turkey. It's quite a big power plant, and we offer the full O&M services for that plant. Another example is our plant in Ashta, where Verbund Group has also 50% share in the project, and the role of Verbund Hydropower was the owner's engineer role and also the setup of a 35 years O&M contract. Another example for our role as owner's engineer is a project in Austria, Switzerland, Gemeinschaftskraftwerk Inn, where we have also had some shares in the past, but now not anymore, and we are focusing now or limited our role as an owner's engineer, as I said. And one of our latest example, a project which is also still ongoing, is a consulting project in Nigeria, where we are trying to identify improvement optimization measures for improving the operation and maintenance. Also two very big power plants, as you can see. Other ongoing projects are in Latvia and Laos, Israel, so quite distributed over the globe. Even in Vienna we have the one. The Verbund Hydropower generation portfolio. We have 108 hydropower plants in Austria, Bavaria and Albania, as I told you, 106 of which are run-of-river plants. It's a total output of almost 5 gigawatt. You can see on the map on the slide where they are located, basically on all of the big rivers in Austria, starting with the Danube, of course, and Inn, on Drau, Salzach, and so on. Another 22 power plants of the storage and pump storage type we have in the alpine regions of Tyrol, Salzburg and Carinthia, also representing quite a big number of output, almost 4 gigawatts. Our portfolio is quite broad. We have 455 units, from quite small to quite big, of all different suppliers, of all configurations, and aside of the turbine generator units, the base, or the core equipment of a hydropower plant, there is a lot of other equipment to be operated, as you can see on that slide. Most of these power plants were built already a long time ago. What did we do the last 15 years, let's say? We still finalized or still working on another 20 larger HPP projects in Austria, I would like especially highlight our projects in Limberg and Reisseck, 2 pump storage power plants. I will explain a little bit more about these 2 plants a little bit later in my presentation. Now we come to pump storage power plants. I guess you know in general the configuration is very simple, an upper and a lower reservoir and a pump turbine unit in the middle operating there. Reality is not so simple as normally. In our case, it's an integral part of a bigger power plant group in the Alpine regions. But however, this technology is a very, very mature and long-proven technology. It allows very large capacities, typically above 200 megawatt. It has highest efficiencies for the storage of electrical energy and high flexibility. So in 60 seconds, you can go from 0 to full load, which is quite substantial. So to our opinion, this represents a really cost-effective, large-scale storage technology today and also for the future. If we have the advantage of the Alpine topography, which we have as Verbund Hydropower, we can add to the list of advantages of such plants a few more. We are able to use large reservoirs, large volumes for seasonal and day-ahead energy reallocation. We can also use natural inflows in addition, and we have very high heads, which results in very high output. So just a little overview about the Alpine region. You will see then in Austria, we have installed capacity of almost 5 gigawatts of turbine and almost 4 gigawatts of pump capacity. All neighboring countries are in a similar size, and in total in this region there are 18 gigawatts of capacity installed, which plays quite a key role in the integration of renewable energy today and in the future. Pump storage facilities have their troubles also. Don't want to go into details here, but just say that the cash flows which can generate from spark spreads are going down quite substantially the last 10 years, which of course doesn't make it easy to finance projects and to develop projects. On the other hand, there is an increasing market of grid services. So what we really miss for the moment is a long-term reliable market model on which we can base future projects for pump storage power plants. What have we done in the last years to increase the flexibility of our generation portfolio? I mentioned already the Limberg 2 pump storage power plant, which we finalized 2011. The project itself also already started in 1995, and we got rather quickly a construction permit 2 years later, but then we had a little disturbance, let's call it like this, which we call the liberalization of the electricity market. So the project then was really started to be constructed in 2006 and then finalized 5 years later. It consists of 2 pump turbines integrated in an existing system of storage power plants. Has a capacity of 480 megawatt and a discharge of 72 cubic meter per second. There was no additional reservoirs needed for this project, and everything was built underground in the mountain, basically. So not a lot to see from the outside except the infrastructure around. Quite similar is the Reisseck project, a little bit smaller, but also an extension of a power plant group in our power plant group in Carinthia. We have been a little quicker there. We started the planning in 2007. 2 years later, we got the construction permit, and in 2016 we started commercial operation. Again, 2 pump turbine units with a total capacity of 130 megawatt is installed there. Again, everything was built underground, and one special issue which is mentioned here is that the works had to be carried out in the high alpine region, so 1600 to above 2000 meters height, which made the construction of this plant quite difficult and challenging. Apart from the pumped storage power plants, this just shows the operation, typically weekly operation of the two plants which I've just shown, and you see very typically in the night pumping, in the day turbining, and you can see in the weekend then almost pumping all the time. So this is very typical and just shows that the plants are used basically 100%. Apart from the pumped storage power plants, we have some other projects, smaller projects to add flexibility to the grid. One of them is the Project Blue Battery, where we managed to widen the primary control band of one of our Danube River power plants by adding a battery. So most of the control service is done by the battery itself, and the contribution from the turbine comes a step later into this primary control scheme. And the reason or the idea behind is that to reduce the movements of the mechanical system of the turbines, which were originally not designed for the use of a primary control. Coming to my last slide, I want to summarize about the pumped storage power plants. As I said already, very important issue is a very reliable technology, and around for almost 100 years. It provides a reliable, renewable and high flexible output, and we consider to be really essential for the future development and integration of renewables into the grid. And also considering the very high overall efficiency which can be provided by this storage technology as compared to other technologies. There are other alternative solutions. We are of the opinion they all have to be investigated, they all have to be used. They may be in competition from time to time, but we think we should more consider them to be in partnership to grant a high flexibility and grant the possibility to include more renewable sources into our grids in the future. So this was basically my presentation. Thank you very much for your attention, and I'm open to questions.
Thank you very much. Very interesting. Are there any questions for Mr. Reich at this point? One, if not from the audience, then one question from my side. The amount of hydro generation in Austria is around 65 or 70% of the...
Yes. Yes.
And what are the plans to extend this amount in, let's say, between now and 20 years from now?
In terms of overall generation, not including the pumped storage facilities, of course, possibilities are limited, we have to say, because we have just one Danube in Austria. We will get a second one, I guess. And there are a lot of projects, smaller projects, refurbishment projects going on still. We are working on them. But from that side, I don't think that there will come a lot of new renewable generation. Yeah. We have to face it.
And limiting factors are, say, technical factors, such as there was only one Danube, or is it also correlated to political, environmental issues? Or what is the difference between the technical potential and what we are
Well, in general, I think it's well known. It gets more and more difficult to get the permit for a hydropower plant. Also, although it's green energy and you have a lot of obligations anyhow, to cope with the ecology and so on. For a lot of projects, it's very difficult really to get a permit to construct and to build. And a lot of, I think, potential developers, also of smaller power plants, really do not get forward with their projects. Yeah, we are facing the same issues. We are busy with developing a few power plants, pump storage power plants. Although we are not sure when and how and under what conditions we will get the permit. Yeah, but nevertheless we develop them to have them ready when the time is right.
And let's say, what I've always been wondering, let's say, when we're talking about 100% renewable or pushing renewables, do you feel from a political perspective they are more eager to allow projects like these in the near future or further future, or will it be?
I'm not a politician. Would I be one? I would say yes, of course. But really, it is more difficult as we see. What we are requiring is really to set up a level playing field for all players in the market. This is a very important issue for us, I think, and let the technologies compete with each other on this level playing field and see what is the best solution and what combination of technology is the best solution. We do not feel that this level playing field is right in place.
Okay. Thank you for your inputs.
You're welcome.
Yeah, let's give him another round of applause. So then I would like to introduce the second but last speaker, Nicholas from Enedis, actually director at Enedis. Let me. Seems like the presentation is stuck, but help is on the way. So as I said, Nicholas from Enedis will emphasize how the role of DSOs are changing or have to change to be fit for the future, let's say. So I'm very eager to hear his inputs. So thanks a lot for the support. Nicholas, the floor is yours.
Thank you very much for your long introduction because of technical problems. My name is Nicolas Wojnarowski. I work for Enedis, which is the DSO for 95% of the French territory. And I am deputy director for the local authority department. Basically, my job is to develop and implement some solution for accompanying local authority in their energy transition. Renewable energy, how does the role of DSO evolve? This is the title of my presentation. Everybody knows here that the increase of renewable represents a huge challenge for DSO, and we have seen that in the other presentation. It's a huge challenge. Maybe the basic issue is to be able to deliver a very high quality of service, high voltage quality, with more and more renewables connected to the grid. So every DSO in Europe and all over the world have been tackling this issue for several years now, and as the other DSO and maybe with a leader role, Enedis developed some, let's say, internal solution, smart grid, smart meters, automatization of the grid, and so on, to tackle with this issue with the increase of renewables connected to the grid. In fact, I won't deal with this technical issue in my presentation, maybe before because I'm not from the technical field, but also because I would like to emphasize another issue, which is, let's say, a more political or societal issue. We are strongly convinced at the level of Enedis that the DSO has a key role in the energy transition. But we are also very strongly convinced that it's not possible for a DSO to handle the issue of the distribution network alone to allow relevant and efficient energy transition. We are convinced that we need to work on the energy transition issue with a lot of different stakeholders. Of course, national bodies, regulator, but local authority, suppliers, urban planners, companies from the real estate world, companies from the IT world, and obviously citizens. And so we've been developing for a few years now some, let's say, external solution to empower all these stakeholders to facilitate their work about the energy transition and to be able to facilitate the work of the collectivity as a whole to achieve very efficient and relevant energy transition. So I will try to give you a quick but broad range of our solution, of the solution we've been developing with these external stakeholders. And I will structure my presentation with 3 domains of solution and with, as you will see, some concrete illustrations. First domain, the data domain. We are providing a lot of data to all these stakeholders to empower them. Of course, simple data, but also enriched data, because our goal is to give some data as valuable as possible for these external stakeholders. The second domain of solution deals with optimization of the local energy potential, and here we will have some illustration about flexibility. And third, I would like to present you a solution which aims at preparing the future, analyzing some long-term energy scenarios, and especially, as far as the DSO is concerned, the impact on the distribution network. First, for the data solution, some illustration from our open data. I have to acknowledge that Enedis is a little bit proud of its open data, because we were the first European DSO to provide such an open data. And here you have 2 illustrations with generation, production data from, in this example, solar panels, and which you can find on our open data. The A illustration, with the A illustration, we provide some this generation data at a level of an administrative perimeter, which is called in French My Iris, and which is a perimeter where you can find between 1,000 and 5,000 customers. This perimeter is very useful for the stakeholders. Why? Because you can find with other sources of data some administrative data in this perimeter. Let's say age of the building, societal data, societal characteristic of population, and so on. And so for our stakeholders, crossing this administrative data with the energy data that you can find on our open data, you will be able, for instance, to define some renewable trajectories, the most relevant possible. In the B illustration, here we have a broader geographic perimeter. This is the department, the administrative department perimeter. France is shaped with 100 departments, in fact. And what is very interesting with this illustration is that you can see the evolution of behavior as far as production is concerned in France, especially for the low voltage area. Here you have in this chart the evolution of the number of solar projects during the former years. In light yellow, you have the production projects where the generation is totally injected to the grid. It's totally sold to the market, being injected to the grid. In middle yellow, you have the generation which is partly injected to the grid and partly self-consumed. That means that the production is only produced to be consumed at the level of the connection point. And in dark yellow, you have some installation for which all the generation which is produced is self-consumed. There is no injection to the grid. And so with this chart, we can see the evolution of production behavior on the trend of self-consumption, in fact. Second example, as far as data are concerned, and I hope that this is a good example of enrichment of data that we are doing at the level of ADEs to empower different stakeholders of the energy transition. We launched during last summer a grid simulator for low voltage installation. With this simulator, you will be able, with your internet account, to have a very quick assumption of the conditions under which we will be able to connect the generation capacity to the grid. You will give, as you can see above in this slide, you just have to enter some geographic information, the address or the geographic coordinates of the production point, and you enter some very quick electric information, power that you need as a consumer or as a producer, and you will have a very quick assumption of the condition under which you will be connected to the grid. In this example, the yellow color means that entities will have to reinforce the network because we have some middle network constraints, and so the consumer will face some additional time and some additional cost. Had the color been green, it would have meant that with the current network, there is no problem to connect the installation, and so we can do it very quickly. Second domains of solution aiming at optimizing the local energy potential. In this first one, we are dealing with the medium voltage area, and we are in the connecting phase. Let's imagine project, generation project, and we are in a zone where the network constraints are a little bit high, and so if the producer asks for a regular offer, we'll say that we will have some times delay and some cost to connect the installation to the grid. We are experimenting some new connection offers, and this is this one. We'll say, all right, if you accept not to inject during certain period of times when the network is under strong constraints, so we will be able to connect the installation quicker and at a less expensive cost. In this situation, we could reach a kind of win-win situation. For entities, we have to realize less investment and less work, and for the producer, he will have a quicker and less expensive connection. Second example, illustration, as far as the optimization of the local energy production is concerned, a kind of, I'll say, the flagship of the way entities accompany territories towards the energy transition. This is a self-consumption, the collective self-consumption solution. The word collective is very important. Here we are dealing with typically local energy communities, people we have tried to gather in an operation with producers, local producers and consumers. And they will make the decision to share their production at a local level, defining, let's call that an allocation rule, which will say which amount of local production each consumer will have at the end of the day. And so, because Enedis and the public network manage the operation and the network in this perimeter. Enedis will take into account this allocation rule and measures all the energy flows, consumption flows, and production flows. For that, we need some smart meters because we have to do that with a 30-minute step, and we do it with our Linky smart meter. We are launched in a large-scale development of smart meters in France, as you know. So we will measure all these flows and calculate, taking into account the allocation rule, what kind was share of local production is affected to each consumer. And after that, we will provide all the relevant information to all the stakeholders of the operation, customers and producers, obviously, but also, and you can see it in this chart, what we call residual electricity suppliers, because it's very difficult to have a total balance between production, local production, and consumption at the level of the operation, and so very often these local energy communities will need some energy coming from outside the zone, some centralized energy, let's say. Third domain of solutions, the preparation of the future. I wanted to finish my presentation with this illustration and this solution because I think that it's a typical example and a very good example of how we have to work all together with all the stakeholders of the energy transition if we want to reach a real efficient, a real relevant energy transition. In this solution, all these stakeholders, let's say at the level of a big city, for example, which want to define its energy mix for the future on a long-term basis. So the city will put around the table all the stakeholders, different infrastructure energy managers, the DSO, but also the manager of the gas infrastructure, the manager of the heating system, and so on. And we will have the urban planners, we will have some citizens, we will have some real estate company, and all together we will work on different scenarios for the long-term energy mix. And after that, the role of Enedis, as far as France is concerned, the role of the DSO, is to analyze all these scenarios and give all relevant information to the whole collectivity, saying, okay, on a technical and financial point of view, we will give you all the impact of each scenarios. And so, with this relevant information, the local authority will be able to make the best possible choice for his long-term energy scenario. That was, in my opinion, a good example of the change in the way of work and in the way under which we work for define the future energy landscape. That's all over for my presentation. Please feel free to ask some questions. Thank you.
Thank you very much indeed. So, I guess there are some questions from the audience on this. Two.
So in one of the first slides, you show the results of like the volume of the energy that is I think consumed from like the central supply versus the one that is locally supplied. And is that like household consumption, like unit consumption, or is it more of like also presumption included in terms of the local grid there? And how much are you seeing the problem of presumption within the local distribution grids too?
It's typically household consumption. Okay, it's solar panel production, which is totally consumed at the level of the household.
Okay. Thank you.
the second one.
Thank you. Can you go to the slide for the local energy communities? What is it, the advantage for you as a DSO to deliver that service to the local energy community? Do you ask money for the service, for the data, for?
In fact, as a DSO in monopoly in France, we are paid to match the needs of the population. And we have observed that for maybe financial criteria, but from time to time, from societal criteria, people want to self-consume, want to have the production, the local production, directly affected to local consumers. And so we had to find a solution to match this evolution of behavior. We are paid. Currently, we are paid by the global tariff to deliver such a service. But once again, the advantage for Enedis to deliver such a service is to show that we are a modern DSO and that we are not from the old world, but we just want to fit with the evolution of behavior. And we think that self-consumption is a strong evolution of behavior.
And is there a financial advantage for the members of the local energy community itself?
I guess so.
You're not sure?
In fact, this is not my business. My business is to give some relevant information about the cost for the network. And if you have some with such a solution, this is not this one. We are able to have less constraint of the network. Maybe we will be able to deliver a lower tariff, and so they will have this incentive. But as far as today is concerned, I think that the financial advantage, this cost, is in the supply side.
And is it just for an already existing grid, or is it also you deliver the service for new grids, where you don't have to invest more in new grids and that you can do it with the existing grid?
Currently, because this solution is now industrialized, but we have just a few cases. We have a lot of projects, more than 100 projects at the level of France, but we have a few projects we are really in place, and we have made them with existing grid.
Yeah.
Okay, a few one in existing grid, but I have just at least one in mind with a new grid. Yes.
So there's always a physical constraint. It's locally. It's not the south and the west of France that is going together in a local energy community.
It's a very good question. On the point of view of network manager, we are very interested in looking at the things at a local level because it's better to work with network constraints. But we have some works with external stakeholders to work with such community at a more large-scale level. But everybody has to know that if you do that at a very, very large-scale level, we won't have any positive impact for the network.
Okay, thank you.
Right, interesting discussions. We can proceed with them during the panel discussion as well. Thanks again, Nicolas, for your presentation.
Thank you very much.
Then we can jump to the final presentation. Just 1 second. Yeah, the final presentation is, well, we actually have two speakers, Ms. Marleen Marx and Mr. Werner Beba, both working at the Hamburg University of Applied Sciences. Ms. Marx is a project manager for the project 4.0, new 4.0, and Mr. Werner Beba is director for Competence Center for Renewable Energies and Energy Efficiency at Hamburg University. So the presentation is about the project 4.0, covering sector coupling and system integration. So Mr. Weber, the floor is yours.
Yeah, good morning, ladies and gentlemen, and I send you the various greetings from northern Germany. And what I mean northern Germany is Hamburg and Schleswig-Holstein, about 4.8 million inhabitants. And what we present to you is a huge practical test. It's a demonstration test with 65 partners from business, science and politics, about 100 single projects, 25 demonstrators and 6 use cases. And this project has an investment about 150 million euro, which is supported by 46 million euro by the federal government of Germany. And the idea is to make a showcase, a blueprint for the energy turnaround in Germany. And the first slide, I very often show it when we discuss about renewable energy and why are we doing this. And you see the simulation of the Hamburg Climate Research Institute, which shows us how would go up the temperature, the global temperature on Earth. And on the right side, when we do nothing, you can see at the end of the century, there will no actors more on Earth with 60-meter water height up. And the left side is when we reach the 2-degree target. But what we also see is that there are some damages because the climate change, which we cannot bring back. So that we have to be quick, and decarbonization is a very, very strong target also for our project. And I show you a short video about this project.
Holstein, a land of horizons and far-reaching views. When locals say, you need to look over the dike, they mean that you need to focus on what the future will bring. Theoretically speaking, Schleswig-Holstein alone could cover its entire electricity needs from renewable energy today. Hamburg is Schleswig-Holstein's direct neighbour. Not only is it the gateway to the world, but the harbour, airport and major industry located there also make it the centre of an economically successful metropolitan region. Both federal states have set themselves a common goal: to develop a stable, sustainable and affordable energy system of the future and to practice effective climate protection, based on 100% renewable energy from 2035. After all, Schleswig-Holstein as an electricity exporter and Hamburg as a major electricity consumer have the ideal prerequisites to enable them to become a driver of innovation in the energy revolution. The most important task facing the future of energy supply is the challenge of developing a stable system in which production and consumption are matched by using cutting-edge communication and monitoring technology. An innovation alliance of 60 partners from the fields of economy, science and politics has accepted this challenge and made it their task to develop the energy system of the future by taking part in over 100 smaller projects. This energy system guarantees a real-time balance between energy supply and demand. Private households and companies will be linked to energy suppliers via intelligent meters. This will produce a more concrete picture of their respective needs and enable energy consumption to be managed in a more flexible and cost-effective way. This includes, for example, developing efficient methods that aim at storing the resulting energy surplus with as few losses as possible, being able to feed it back into the network in times of increased demand, or to transform the surplus electricity into other energy forms, making it available for heat supply and the mobility sector or the industry. Like this, the electricity transition becomes an energy revolution, which has an impact on all aspects of life. The success of the energy revolution depends on the interplay between sustainability, cost-effectiveness, and public acceptance. This means that by investing in a growing future-oriented market, competitiveness and market opportunities can be strengthened. The regional economy benefits. Modern energy systems remain affordable for end consumers, and energy supply is secured over the long term for citizens. It also means that any economic decisions are made with the focus on clean energy to reduce CO2 emissions in order that future generations will not be burdened with problems that we did not want to solve. This means that the entire region will become a role model, showing others just what climate protection should look like in Germany and across Europe. Let us not waste this chance.
The main task in our project is for the overall goal 2035, 100% secure and stable electricity system and 50% decarbonization in heating and mobility leads us to 80% reduction of CO2 emission in this region, where we combine Schleswig-Holstein as a region of production. They have about 128% of their own usage, of their own demand and electricity production of renewable energy, but Hamburg has only 4%. And this typical picture, a region of production and region of consumption, we find overall in the world, from Paris over Barcelona, Shanghai and so on. Cities will grow up and they cannot produce their energy demand in all sectors in their own region. The second one is the decarbonization. Today we have the problem in Germany that we do not save CO2 because the system change needs too much reserve capacity which come from nuclear power plants or coal power plants. So we have to solve this problem of the system stability by synchronization of demand and secure. And the third point is to integrate it in a functionable market, very important. And so this project is a 360-degree project where we improve and test all this. So the strategy is a dual strategy. So the first question is how can we increase the electricity export in other regions through the efficient use and development of the energy infrastructure. There are a lot of points of ICT, the real-time communication between DSO, TSO, all producers. Wind energy is a famous renewable energy production in this region, and also on the demand side. We focus on the demand side very on the industrial hub of Hamburg. Hamburg is the most central industrial center there of Germany. So we have three companies. ArcelorMittal is a steel company, Trimet aluminium, and Arubis a copper. Each of these companies has an electricity demand like a city of Braunschweig, I don't know, in Austria. So it's a huge demand, 27%. So demand side management for industry is a very important effect for us. The second point is how can we increase the local energy self-utilization via introducing flexibility measurements and sector coupling, converging the power in other energy forms, heat, mobility, hydrogen. Today, we have in Schleswig-Holstein 3 terawatt hours feed-in management. So the yearly demand of 3 million households we cannot bring to the grid. So for this the double strategy is very important, and we use different, very technology open forms: battery storages, high temperature storage, virtual power plants. We use market platforms, which Marlene will present later, power to heat, power to gas, CHP, and power to steel or power to steam for the industrial side. 65 partners, 100 projects, single project, 6 use cases. Our 6 use cases where a lot of projects work together are first, a fast intraday trading focuses on part 1 of the dual strategy. So in between 5 minutes to transport electricity to the demand side and to the market. And so that needs a total transparency in real time of the grid situation, so a real-time data communication and a real-time marketplace. I come later on. Use case 2 is a real-time grid monitoring, especially there where we have feed-in management. And this is called in German the Netzampel. I don't know the right English word for it, the traffic light system, so red, green, yellow, and focusing with the market platform on it. Use case 3 is a smart balancing. Use case 4, reserve capacity from renewable energy generators and also on the demand side. Use case 5 is a fast frequency response, inertia, and use case 6, decentralized reactive power supply, which the idea is about 2,000 wind turbines put together, bringing reactive power, because reactive power is very important in regions where you have so much feed-in management on the grid. This is an overview of our demonstrators. We have a 200 megawatt flexibility, different types, battery storages, electrolyzer, demand-side management activities, and so on. The very important point is we found out under our first results, 2 years of the project are over, more 2 years are running, that the demand-side activities on the industrial side, they bring reserve capacity on the one hand, and on the other hand, with the same system, they reduce the direct fossil fuel. For example, instead of gas using in a steel company, they use electricity, renewable electricity. So 3 important roles for the decarbonization of the system. And we have 2,000 megawatt virtual power plants which are in real time on a database system worked together. Strategy number 2 is very important for this electricity sector, bringing it to the other sectors, and this will Marlene Marx present to you.
Yeah, thank you for the introduction, Mr. Weber. As Mr. Weber just gave you a short overview about our project, I will give you an insight of some of our demonstrators. So one of our biggest demonstrators is a battery storage of the company Inspire Me. It's also one of the biggest battery storages in Europe. I think only Great Britain has a bigger one. This battery storage has a capacity or installed power of 48 megawatts, and there are approximately 10,000 single accumulators installed inside there. And we can just store the electricity for approximately 5,300 households for 1 day with this. This battery storage is operating since June this year. It's participating at the primary reserve control market. And another thing which we want to test also in our project is the reactive power supply. We have 0.8 PU with this storage. This means we have a reactive power capacity of about 38 megawatt. Yeah, another demonstrator is from the company Vattenfall. Vattenfall operates in Hamburg the so-called Caroline. It's an electric heating boiler, and it's running since 30 years now. But now Vattenfall they are going to renew it, and the operation process is taking place right now, and it will operate, or it will produce heat hopefully the next month, and then we can just produce heat for approximately 13,000 households in Hamburg. In former times, this boiler only was used for peak loads or when we have blackouts in other heating power plants. But what we want to do in the future is that in the future we also want to use these as a power to heat system. We want to use the excess electricity which we have from the renewable energy systems in Schleswig-Holstein. We want to transport this electricity to Hamburg, and this excess electricity we want to produce the heat out of it. Yeah, as Mr. Weber also told you, we have a big industry in Hamburg. One of our industry partners is ArcelorMittal. and yeah, they have a very, very energy demand, especially for the melting of the steel. And until now, the melting of the steel, yeah, works with natural gas. But ArcelorMittal just decided, okay, we just want to change this. We want to install a preheating before the gas oven, and the preheating will have an installed power of approximately 10 megawatt. And the first results of a feasibility study for this preheating just shows us that ArcelorMittal will save approximately 7% of CO2 with this project. Then we also cover the sector of hydrogen and also mobility. Nearby the Danish border, we will build an electrolyzer, 1.3 megawatt, and also we want to feed in the hydrogen into the natural gas grid, but we also want to build a fuel station that we can fuel hydrogen cars with it. Yes, and now one of our use cases, also Mr. Baber just showed you, we have 6 use cases in our project. One use case is the grid traffic light. So what has happened, or what is happening today in our grid? Today, when we have congestion, it is solved by curtailment of the renewables. We have feed-in management, but we don't want to have this in future. So we are looking for solutions. How can we reduce this feed-in management? And our partners, the Schleswig-Holstein Netz and also the ARGE Netz, they just developed a platform, the so-called ENCO. And this platform we can we can bring together the flexibility and also the grid congestion. And here there's just a picture how it works. On the right side you can see the grid operator. The grid operator they do a forecast of the congestion for the following day. And this forecast they publish on the ENCO platform. And the flexibility providers on the left side, they have then the chance to offering their flexibility to cover or just to cover this congestion. And this is a day ahead process, and but we hope that we can reduce the grid congestions and also the feed-in management in our grid. What is the next step? As you know, we have about 100 different projects, 25 demonstrators. As you see, the different colors, they are the different technologies. As Mr. Weber told you, we have a 360 degrees technology approach, and our aim is just not to regard our demonstrators as a single demonstrator. We want to regard our demonstrators as a whole holistic system, and we want to have a look how all demonstrators are working together. And we have to find a testing time period. This will start at the end of the next year and will reach up to the end of 2020. And also, as Mr. Weber told you, our goal is that we want to have in 2035 100% of renewable energy systems. And how can we solve this? So we have to reduce the need for the functions which have covered by conventional power plants up to now. So we have to reduce the need for reserve capacity, we have to reduce the need for redispatch, and also we have to reduce the need for mass run capacity. And as you can see on this slide, all of our 6 use cases are able to reduce one or more of these things. And also, in addition to this, when we don't need the conventional power plants anymore, we will have a very high reduction of the CO2. Yes. Thank you so far.
Thank you to both speakers. Are there any questions from an, I guess, already hungry audience? If not, I have one short question. Maybe you thought of this in the course of your work or your projects. Because you put a lot of emphasis on the industry in the Hamburg neighborhood, are there any estimates how much technical potential there is from this industry to provide flexibility to support grid operation?
You mean the potential of the industry?
Yeah, well, potential of flexibility within industry in terms of kilowatts or megawatt or megawatt hours, let's say.
I couldn't tell you a number for Germany how big the potential is, but the potential is big. At least in our project, the project of ArcelorMittal is not the only project. ArcelorMittal has got 2 projects of about flexibility of about 30 megawatt, and also our other industry partners have the same size of flexibility. And this could only be the start. There is much more potential in there.
Okay. All right, then thanks a lot again for the presentation. Yeah. And then we will jump to the closing panel discussion. So I would like to ask the panelists to join me on the stage. So we have Mr. Gregor Taljan from Energienetze Steiermark, Mr. Milan Vukasovic from APG, Ms. Natalia Romero from TU Delft, Mr. Reich from Verbund, and Nicholas from Enedis. So maybe you can. So, though the audience got a bit thinner, I guess some people are getting really hungry. I was hoping to get quite some questions from the audience during this panel discussion. After all, you are interested in this session, so feel free to put your hands up and none. Maybe you have some questions for each other, like something which was highlighted in one or the other presentation to which you fully agree or disagree. Maybe some things that would need some more attention or highlighting.
Perhaps I can take the role of breaking the ice.
Thank God.
Well, what is of particular interest to me are the local energy communities. There's a big discussion currently, probably not only in Austria, I think you mentioned also in France. And in Austria we are following 2 different concepts. One concept is about private networks to be built to allow local energy communities to function, and the alternative is to use the public grid with reduced tariffs. And in this context, I wanted to ask you what is the position of Enedis in this discussion? Do you also have like same discussions, same concepts, or do you think, or are your ideas going in totally different direction? That would be perhaps from my side.
Thank you for the question. As I tried to show during my presentation, Enedis want to show to the electric world and electric stakeholders in France, but in other projects in Europe maybe, that we are totally able to help to empower some local energy communities with the public network. And to be honest, my point of view is that this is not a question of system of ownership. I don't know if the network is private or if this is public network. Technically, we just have to manage to make this operation work, and it's possible to do it with a public network. After that, what is sure is that the projects that we are leading with this collective self-consumption solution are implemented with the public network. And so consumers in the operation take the benefit of the public network in terms of quality, low voltage quality, tariffs, etc., etc. They can choose their suppliers if they want to change some their residual suppliers. They can do it. So we can make the rule of the market play at the level of the local energy communities, but we can also accompany this evolution of behavior because people want to self-consume this production. That's my point of view.
I have one question which actually concerns all network operators. So it seems, based on the presentations I saw today and other projects going on, I have the feeling that despite an ever-increasing amount of renewable generation being connected, there are solutions, and we are able to deal with this, at least up until now. There are solutions on the transmission grid, there are solutions on the distribution grid. A lot of it is being demonstrated, proven to be working. So my question to you is, taking into account all of these solutions and the things you're already doing today, what are the main challenges you expect for, let's say, between now and 5 to 10 years to cope with in terms of integration of renewables in the grid? And it's open for both DSOs, APG, Verbund, of course.
So thank you. I think I tackled this one already partially in the presentation. You saw the problems that we are facing with also nowadays. We are trying to solve them with the remedial actions, which is not that always as a optimal. And we think that with the time there's going to be additional renewable energy sources integrated all over Europe on top of what we have also nowadays. We have limited, I would say, storage capacities when it comes to the pump storage. In Austria, thanks God, we are quite good with it. But I think the possibilities are quite limited. So we need a new solution, how to store this excess of electricity. At the same time, we saw that I think the new technologies are not only solution. We will for sure need strong transmission networks to cope with such problems. And I think what's also important is to ensure the coordination on European level, to sit together, see from the European perspective when we need to build new valuable lines in order to increase, let's say, benefits for all the parties, or as mainly consumers in Europe, and to try to estimate, let's say, different possibilities to cope with this. Is it new transmission line to be built? Do you need to change a market design to cope with this problem? Or at the end, if you have, let's say, and this is a goal, to have overloads which are not, let's say, of a structure, like a structural congestion, to cope with this during the limited number of hours during the year. And I think this is the efficient solution for the future, to bring all those, let's say, parts of a puzzle together and to work into direction of ensuring, let's say, transmission and distribution grid of future together with the different market players, regulators, aggregators, and producers, suppliers, and so on. Yeah.
Okay, thank you. Is there any things you want to add from a distribution network operator perspective? I guess the challenges for a DSO and a TSO are not entirely the same.
No, I don't know if what I will say will be very valuable, but I think that there is a huge field with storage I think that as a distribution level, as a DSO, we have some work on some. We have to know how to handle with storage. Is it a good thing to have some storage capacity at the level of the DSO? I think that we will see some huge progress in the storage field. And as far as the energy transition is concerned, it will be a very, very interesting tool to reach some relevant policies.
Well, in Austria, I think the challenges for DSOs and for the TSO are quite different. You have to remember or consider that almost all or 99.99% of renewables are connected to the distribution grid. For the state of Styria, I don't know any of PV or wind installations that are connected directly to the TSO grid. So we as DSO are definitely facing huge challenges, especially if you then consider in the next step the governmental obligations or goals in the Mission 2030 program, which says that the PV and wind installation should be 7 times higher than they are right now, I think. And I said in my presentation that we have right now 15,000 PV installations in our grid, and then if we would fulfill those goals for 2030, we would then have 150,000, which is of course huge difference. Every year we would have to build or connect as many PV installations as we have right now in our grids. And right now the problems are not that big. They're locational. I mean, we have some points in the grid where we have problems, but once we reach or we get higher into 50 in the direction of 50,000 and 100,000, we will definitely have massive problems in our grids, or we expect more problems, and that's why we are developing the solutions right now.
And yeah, please, you can add to this. Just as a short question, and do you expect the solutions you're investigating right now to be sufficient to cope with those future challenges, or do you expect to need something different?
From my perspective, it's always better to have more options, more solutions than less. And we are definitely looking in different directions where to get these solutions. One is, of course, new technologies like regulated transformer, like the low voltage grid controller, so on and so forth. The second is from flexibility area, storage, and then the flexibility of the customers and switching of customers. That's also another solution. But we are trying to get a whole broad spectrum of solutions, because we also think that there won't be one solution fits all sizes. It won't be possible. You won't be able to make or to correct every problem with only one solution. So that's why I think that it's very important to be innovative, to put a lot of energy into innovation, and to be also broad and to try everything, and then on the long term the time will decide which solutions are really the most efficient for the DSO.
I just shortly wanted to say a few words about, let's say, the services which are useful from the side of the DSO, and on the other side from the side of the TSO. I think there are some similarities when we talk about ancillary services, but there are some huge differences. Yeah. So first of all, I think it's quite true that the most of renewables is of course connected to the low voltage levels, but as it fluctuates very much, and it's pretty located, let's say, in the certain parts of the network, we have a bulk, so huge transmission of electricity from north to south, west and east, and we need to cope with this. So I would say when it comes to the services which are important for TSO, we are mainly considering congestion management services, And the distribution grid, I think the network is not that meshed as the transmission one, so it's a huge difference. Then what is a must for us is to stabilize the frequency. So this is a system service on a global level, and when it comes to the DSOs, I think it goes more into a direction of a voltage stability and a reactive power in feed and so on. And I want also to mention that we are currently started with the project together with a few partners in Austria. One of them is a Verbund. We are, let's say, trying to test the services that the battery could provide also for the transmission system operator. And here we are thinking about the more advanced, I would say, even faster services than the primary control. Yeah? So services to ensure the inertia of a system, to stabilize a system in case of huge outages, and let's say to damp oscillations which might occur in the system. So I think there is a huge amount of services on a paper, and we need to coordinate and work together in order to ensure stability of transmission and distribution system at the same time.
Perhaps one sentence also from my side. I also think that it will be more and more important in the future that the DSOs and TSOs will collaborate more closely, because some things that happen on TSO level may impact DSOs and vice versa. So I think that in the future, and also if you consider that some of the customers which are connected to the DSO grid are going to offer services for the TSO, you may get into the situation that we will have problems because of those customers, because TSO is going to switch them, or vice versa again. So the cooperation, I think, is very important thing for the future, and we'll have to work hand in hand to be able to connect all the additional PV installations and wind installations in the grid in the future.
So there is one more question from the audience. Go ahead.
Yeah, it's a very strange microphone. Do you really hear me? Okay. I want to come back once more on the local energy communities. You discussed it in the beginning of this panel session. I'm from a Belgian DSO. I heard that in France and in Austria there are some difference already how targeting the question for local energy communities. I have the feeling that we all also are doing some things and testing how can we serve the local energy communities. It looks like every DSO in Europe is countering on a different basis. Is that what local energy communities need, that every DSO has a different solution? Maybe it could be, maybe there is a little bit more alignment necessary. We, as a Belgian DSO, we're looking at that it's the most social optimum that they already look the existing grid, or if there is a new development, we as a DSO build the new grid, and it's a public grid, and that there is just a lower tariff, like in France, what you do. Only if they accomplish it, then there is less need for capacity or less energy exchange with the point. What are your thoughts of a little bit more in the same solution for as a DSO? Because I heard from local energy communities, we don't want a grid. Most of them, we are not interested in the grid. We are interested in making more renewable energy, and the regulation is not really optimal for having more renewable energy sources in some countries. Are there thoughts of how we can align that a little bit more?
I think that in Belgium you've just had a new regulation about local energy communities 1 or 2 weeks ago. Is that true? Yeah. I think that a new law has been launched, and now you can handle some local energy communities.
It's just the translation of the what Europe wants. That is, but it's not finished yet.
I don't know if you see if the final objective is that every DSOs in Europe are totally aligned with this issue. But what is sure, and that Enedis is totally open to have some discussion with other DSOs to explain maybe a little bit the solution. And I think that what we built, what we developed in France. As far as collective self-consumption is concerned, it's totally possible to do it in other countries. There is no reason. First point. And so if you want to have some discussion with my colleagues in France, so it's totally possible. I'm a little bit annoyed when I heard something like we want more renewables, but we don't want grids. I think it's not possible. Because as I tried to show it during my presentation, you need a distribution network, maybe a local one, but you need a distribution network, and it's very important for Enedis to say, because we are a monopoly and a public service company, that we have to make possible all different choices of the population. So if they want to balance their consumption between local production and centralized production, it's necessary to make that possible. And I think that the public network offers this possibility. If you want to consume at a local level, you can do it, and you can handle local energy communities with the public network. And if from time to time, for financial or societal or other criteria, you need some centralized energy, I think that it's a good thing as far as our energy solidarity is concerned to make that possible.
So since we are a few minutes from closing the discussion, maybe I would like to ask TU Delft and Verbund to give some final statements if you want, or refer to one of the topics we just discussed and maybe give your insights on this. Maybe the topic local energy communities is something you can hook into.
Well, so what we are looking at is so similar to the question I had about what can happen at the local level with congestion management, and then what we can do with respect to planning algorithms that kind of keep helping to the TSO, like the stability for TSO, but also for the DSO. And I think that looking at it from the perspective of analyzing from the algorithm, what we're seeing is that definitely what they say that like good coordination and communication is going to be very important, because problems can happen, like what that person brought up when I was presenting, that there could be problems, additional congestion management if the kind of at the local level the problem is not designed well. I'm also curious about some of the proposals. Actually, I want to ask the DSOs on this perspective of thinking about installing the storage units that are really meant for that. It's like there is this analysis of like that cost versus using the storage that could already be available there, for example, from electric vehicles or like the transmission system level, like from the hydropower. Is it why are we really considering this solution that is kind of so focused on only one service when we could drive that service from like other options that we could have? Although that's not a closing remarks, more of a question, but that's something that from the perspective of the planning algorithms, I really would be interested in seeing like what those numbers are. Like, how do you compare the cost of having that storage unit versus just the that you can use that storage from like the flexibility you have at the local level?
Yeah,
It's okay.
I may refer.
No, I may answer the question first. I think it addresses our project more or less. Very good question. Our position is that if so cost intensive asset as a storage system is installed in a distribution or a transmission grid, it has to be used for multiple different purposes, use cases. And what we did in our project is we used the storage not only for the DSO, because we know that the DSO needs the storage only for perhaps 400, 500, 600 hours a year, but also for the local customers and also for the markets. DSO is one of the potential market buyers of the services on this market level. For us, for the TSO, the storage, if we invest into the storage, it has to be more cost effective than all other different solutions. So storage is for us only one option, and if it shows out that this option is the most cost effective, we will invest. And on the other side, we won't be the sole investor. That's also our hope, so to say, that the storage, that local customers will take part of the investments because they can store their locally produced electricity into the storage, and this will be one of the revenue sources, and another is, of course, the market. So our share of the storage installation cost should be lower than all the alternatives. And in this concrete case that I've been presenting, because I like to speak in numbers, they are more, they have more demonstrating impact. On this line that we where we have problems, if we would put the line into the ground to cable it, we would pay like 50 to 70,000 euros. The low voltage control would cost us roughly about 30,000 euros, and storage solution has to be cheaper. So if storage costs 100,000 euros, we would provide 30% of the investment, and the rest has to come from the market and from the customers.
Yeah, may just come back to what was said earlier about the requirement of distribution grids, the local distribution grids. Of course, they are required. There's no doubt about that. But I want to emphasize also that transmission grids in the future will be a very, very core element still, and they need to be strengthened. Anthony, you said earlier that we can obviously cope with all the problems we have up to now, and you presented very well that you can cope with it. Although it's very costly, we can do it. We still can do it, which is a good and required thing. Which, on the other hand, may lead to a situation where the awareness, let's say, of the public and also of the political level is not as it should be. I mean, if you're asking in your private environment whether they are very concerned or whether it will become dark and they will not have electricity, at least in Europe you will get the answer no. It was always there. It will always be there. Yeah. So there is no awareness in the public, and what is in the public is reflected, mirrored at the end in the political level also. And I guess we have to all together to work on this level also to convince politicians to enable this enforcement of our transmission grids also. It's not a solution if we have, like in Germany, a problem with transmission grids which are too weak, that we find workarounds all the time with the congestion management. Yeah, this should not be the way. And a world without transmission grids, I would say, is for me not really imaginable. It would be like a world without motorways and without long distance flights, and I think this is not the direction we are going to.
Okay, thank you very much for those closing words. We are out of time and almost out of audience, but still it was an interesting discussion. Thanks again, everyone, for your participation, your contribution. Thanks also to the audience, and have a nice lunch break.